let's compare negative ions versus atoms. Compared to the atom it came from, a negative ion is going to be larger and will have a lower ionization energy. And the reason for that is you're putting more electrons, okay, same number of protons, you're putting more electrons into the outermost shell, so that means extra shielding, okay, so extra repulsions that those electrons out there are going to feel because of that extra additional electrons you're putting in. So extra shielding means extra repulsions among the electrons on the outside, right? So if there's extra repulsions, they're going to spread out more, so your size would be larger. Okay, if they spread out more, they move away, farther away. They're going to be pulled less by the nucleus, and so the ionization energy is going to be lower. It will be easier to remove an electron from out there. Now, if a valence shell is filled, the additional electron will go to the next shell, would be much further away, even easier to remove. So, for example, if you have neon, fluorine, okay, versus fluoride versus F with a negative 2 charge. Okay. Fluorine would be 1s2, 2s2, 2p5, right? So you got a neon core with 2 electrons, and then 7 electrons on the outside. That's fluorine atom. A fluoride would have an extra electron, so more repulsions. It's going to spread out, so fluoride would be larger than fluorine in terms of size. And then F with a negative 2 charge, that second extra electron will come into a much larger shell because the second shell is going to be filled now, so it's going to be much larger than fluoride ion. And so that's in terms of size. Okay, and in terms of ionization energy, then fluorine would be greater than fluoride. It would be much greater than F2 minus. It's going to be very easy to remove an electron from an F ion with a negative 2 charge. So easy, in fact, that you don't find it in nature at all. Okay? So how do you compare F with a negative 2 charge versus sodium? F with a negative 2 charge, okay, we said has a very low tendency to hold on to its electrons. Remember, we said 9 electrons plus 2, that's 11 electrons. So it's going to be the same as sodium. It's going to have a neon core, 3s1 configuration. But what's the difference? So you got a neon core. Okay, so you have, in the case of fluorine, you have 9 electrons, right? You have 9 electrons right here. And you have 10 electrons in the core, and then you have that 1 extra electron outside. Okay? Compare that to sodium, which has 11 electrons in the nucleus, pulling in that electron from the outside. So 9 versus 11, sodium is going to be able to hold on to its electron more strongly than the F with a negative 2 charge. Okay, so sodium would have a higher ionization energy compared to F with a negative 2 charge. And what about size? It would be the opposite, right? So F with a negative 2 charge, if it were to exist, would be larger